All right, so how do we graph an exponential function when a is less than 1? What is it going to look like? So when we look at this, we would take our f of x equals x to the third, and we want to plug in our values. So I would do -2 first. So that would be 3 to the -2 power, or we know if it's a negative, it puts it on the bottom of a fraction. So it's 1/3 squared, which means our f of x value is 1/9. -1, so 3 to the -1 power equals 1/3 to the first power, which is simply 1/3. And then I would go through 0, 1, and 2, follow the same steps. We know anything to the 0 power is 1, anything to the first power is that's number itself. So we get our values of 1, 3, and 9. So now we want to take and graph our points. So this would be -2 and 1/9. This would be -1 and 1/3. 0, 1, 1, 3, and 2, 9. And when we graph it, this is what our exponential function would look like. So it goes infinitely up to the right, and as it's approaching the x-axis, you notice it's not going to ever touch it, okay? It's always going to be getting infinitely closer and closer. So in this case, we know our domain is going to be all real numbers, okay? We know there's not going to be any x-intercepts. In this case, our y-intercept is 1, because anything to the 0 power is always 1. So no matter whether it's 3 to the x, 4 to the x, 5 to the x, it's always going to cross at 1 on the y-axis. The x-axis is going to have a horizontal asymptote. Okay, so if we look at this information pared down, what we just stated, the domain is the set of all real numbers. So remember, with notation on this, you could write this as x with the double-lined r. That's one notation. You could do interval notation using -infinity to infinity, because we know our domain is going to be all numbers. If we're talking range, our range is a set of positive real numbers or 0. So if we write it the way we're doing this, we could write it like where y is greater than 0. And that's another way we could write it other than interval notation. So there are no x-intercepts, and the y-intercept is 1. We discussed why that is. The x-axis, y equals 0, is the horizontal asymptote. And this is an increasing function, and it's 1 to 1, because if we were to draw our horizontal line test, it only crosses at 1 point. So we know that function is 1 to 1. Okay, and obviously we can see the points. Now, another terms to know is this is a smooth continuous. That means there's no corners, there's no breaks, there's no gaps. It's smooth and continuous. So let's look at an exponential function when a is in between 0 and 1. So that means it's a fraction. So if we look at this example, f of x equals 1/3 to the x power, we'll use our same values. We'll put in -2. So the -2, what that tells us is to flip our fraction, okay? Because that -2 makes us 3 squared, which is 9. -1, flip our fraction, 3 to the first power, which is 3. Use our numbers 0, 1, and 2. We know anything to the 0 power is 1. Anything to the first power is itself. And then if it's a positive squared and it's not a negative, that means we just square that whole 1/3 times 1/3. and that's the values we get. So now we need to graph our points: negative 2, 9, negative 1, 3, 0, 1, 1 and 1/3, and 2, 1/9. And when we graph it, you'll notice our exponential function looks different. Previously, and I'm going to draw this using this yellow marker, our line looked like this. So it was the mirror image of it over the y-axis. So if we're dealing with an a that's a fractional number less than 1, then our exponential function is actually going to decrease as x gets bigger. Our domain's the same and our range is the same. We have the same horizontal asymptote. It's going to approach x but never, it's going to approach the x-axis but never touch it. So looking at that information condensed, same thing. The domain is still the set of real numbers. So the domain could also be written as x when, and then use real numbers in there. And if we're talking range, that would be y, and it would be when y is greater than 0. That would be two different ways to list the domain and the range. Same thing as before, no x-intercepts. The y-intercept is at 1. The y-axis is our horizontal asymptote, and our graph is smooth and continuous. There's no corners or gaps.